Alright, let's go ahead and get into lesson 2.3, using the distributive property. So this begins on page 56 in your textbook. So to warm up, we've used the distributive property before, but we probably haven't used it with positives and negatives. So that's where we're going to start to see a little bit of a difference. So remember, when we use the distributive property, we're taking our number that's out in front and we are distributing it to the numbers inside of our parentheses. So in this case, we would be doing 2 times 3 plus 2 times 7. And we're using plus because we had a plus sign in here. So 2 times 3 is 6. 2 times 7 is 14. 6 plus 14 is 20. Again, very similar on this bottom one. We're distributing it. We're taking 3 times 7, 3 times 5. This time we had a subtraction sign, so we're subtracting. 3 times 7 is 21. 3 times 5 is 15. So we have 21 minus 15 is 6. So that's probably the extent to which we've used distributive properties so far. Now we're going to start adding in variables. We might have more than one term inside of our parentheses, and we're going to deal with negatives also. So for instance, this first one, we're going to take the 5 times the a and the 5 times the 6. So we'll end up with 5a, 5 times a, and then 5 times 6. And 5 times 6 is 30. So we'll have 5a plus 30. Moving on down the row here, we have negative 2. We're going to distribute that to a. So we'll have negative 2 times a plus negative 2 times b, which will be negative 2 times b, plus negative 2 times 3. Well, what is negative 2 times 3? That would be negative 6. So we have negative 2a plus negative 2b. Kind of put these in parentheses so we don't get our pluses and negatives mixed up, and then plus our negative 6. And we can remember that we could leave this as all addition and have those plus negatives, or that whenever you're adding a negative, it's the same as subtraction. So remember, adding a negative is the same as subtraction. So we could simplify this. Sorry, that kind of overlapped a little bit. I didn't expect that. Negative 2a minus 2b minus 6. And then our last one, we have negative 3 times x. So we'll have negative 3x. And we'll have minus negative 3 times 7 would be negative 21. And when we have a minus negative, it's negative 3x. This becomes a plus, so plus 21. So we have negative 3x plus 21. So the distributive property in your notes says for any real numbers a, b, and c, a times the quantity of b plus c is the same as saying a times b plus a times c. The distributive property is often used to simplify algebraic expressions. So if it says simplify and you see something like this, you're going to need to go ahead and apply your distributive property. So example 1 says distribute 4a plus 3b. So we have the 4 and we have a plus sign there in the center. So we're going to distribute our 4 times the a plus our 4 times the 3b. Then we'll go ahead and multiply. So 4 times a is just 4a, and 4 times 3b, well, 4 times 3, let's see, 4 times 3 is 12. So we'll end up, this is, once we've distributed, it's 4a plus 12b. Okay, example 2 tells us to distribute. This time we have negative 2 times the quantity of 3x squared minus 4x plus 5. So let's take a look. We're taking our negative 2 times the 3x squared. We're keeping our minus sign here, taking negative 2 times the 4x, keeping our plus sign here, and taking our negative 2 times the 5. You'll notice the way they laid this out, we have our highest term, so x squared, then our regular x, and then the term with no variables. That's just pretty common order to keep your work nice and organized in. So we'll want to keep that in the same order. So we'll have negative 2 times the 3x squared. Well, negative 2 times 3 will be negative 6. We'll have a minus our negative 2 times 4x, which will be negative 8x, and then plus our negative 10. And then again, to eliminate all these minus negatives and plus negatives, this will become a positive, or an addition. Plus a negative, the same thing as saying minus. So we can simplify it once more to negative 6x squared plus 8x minus 10. Okay, so we have some definitions today. And the first one you've probably already heard me say, it's called a term. So a term is a constant, variable raised to a power, or the product or quotient of a constant and one of more such variables. So those are a lot of words that may or may not make a whole lot of sense. I think it's easier if we just kind of illustrate this. So imagine with me for a second that you're looking at, let's say 2 bananas. And these are obviously not the prettiest bananas you've ever seen. We've got 2 bananas and we'll have 3 apples. So I want to combine my like terms. So far we'll say our B stands for bananas, and we have an A that stands for apples. So all together for fruit, I have 3A plus 2B. But can I combine these? No, I can't combine these. If I combine these, I'd like be smashing my bananas and apples together and coming up with like appalanas or banapples or something crazy like that. I have to leave it separate. I have 3 apples and 2 bananas. I cannot combine my A's and my B's. So this is in simplified form. That's all the more I can simplify it. So in this problem right here, I have terms. And the terms consist of different things. So a term consists of a coefficient, which we'll define a little later, along with our variables, and sometimes we might even have exponents. So let's leave our 3A plus 2B. We're done with the apples and bananas now. We're going to move on to this term. This term is 3x squared y z to the 4th. So this is all one term together because we're multiplying everything, so it's glued together. We're not adding, it's not separated at all. This is one full term. And in this term, we have a coefficient. That's the number out in front that tells us how many times we're multiplying this product by. We have our variables, x, y, and z. And we have exponents. So we have a 2, a power of 2. Technically, when there's just one variable, there's an imaginary 1 exponent and a 4. So these are all different parts that make up our term. And that's where they're talking about constants and variables and powers and this and that. So we have our coefficient, which is constant, our variable, our exponents, and this is a product, or it could be a quotient, depending on how it's set up, but they're glued together. They're not being added or subtracted. They're either being multiplied or divided. So this is what makes up our term. Like terms are terms that have the same variable, or variables with corresponding variables having the same exponents. For instance, I can have an x, maybe I have like 2x, and I might have plus 3y, and I might even have plus 7xy. But guess what? This is not a like term to this or this, because they aren't all together. 2 times x is different than something times y, is different than something times xy. Because if we said our x value was 2 and our y value was 3, that would make this value, oops, getting ahead of myself, that would make this value technically 6. So it'd be like saying 2 times 2, 3 times 3, and 7 times 6. So whenever they are glued together like this, we can't combine them because these are not like terms. If I add on here maybe a 5x, now I have like terms because I have another x. So I could combine those. They are like terms. But the rest of these, this y, and even though there's an x and a y, and I have other x's and y's, because they're not glued together, they are not like terms. So terms of an expression are separated by addition or subtraction. So here we go. We have our coefficient and our variable, that's one term. Coefficient and a variable subtracted by, or separated by a subtraction. Then separated by addition, we have another coefficient and variable. So this expression has 3 terms. So in example 3, it says simplify. And when it says simplify, what they're asking us to do is to combine like terms. So if you want to throw that in your notes somewhere, simplify means they want us to combine like terms. This is where it might be helpful for you to color code things. You can use an underlining system. That would be fine either way. So first of all, we just need to identify, do we have any like terms? So we have 3x minus 4y plus 5x. So here we have an x, and here we have an x. So I would use an underline like this. I have 3x, and I have plus a 5x. So I know I can combine those like terms. They even go so far as to rearrange them. We can flip them around, flip the order around here, so we can see them next to each other. And we would know that this would actually be 3x plus 5x. So what is 3 plus 5? Well, here's where that distributive property starts to come in, because we can kind of like reverse distributive property in our brain. So what do these have in common? They have the x in common, which means we can pull the x outside of that and say we're adding the 3 plus the 5. See, if it would have been distributed, we would have been throwing the x to each one of those, which is what we had up here. So this is kind of like going on in our brain. This is what we're seeing happen. And then we can go ahead and add our 3 and our 5. Well, what is 3 plus 5? It's 8. So we'll have 8y minus 4y. Or sorry, 8x minus 4y. And really all we did, we took the 3 on the first x term, and we took the 5 on the second x term, and we added them together to get 8x minus 4y. Now eventually you won't have to do all these steps, you'll be able to just see it, but this is important for you to just see why we're able to do this, how it's actually working. Alright, so for example 4, says simplify, so remember it means combine like terms. So what like terms do we have? Well, we have an x squared and an x squared, and then we have a regular x and a regular x. So we could write those in the correct order so we can kind of see them grouped together. It's really important to pay attention to the signs out in front. There was a negative sign in front of that 4x squared, or a minus. Remember, it's like a plus a negative, so it's our minus sign. We have to keep that attached to that 4x squared. So now we have 7x minus 4x, or sorry, 7x squared minus 4x squared. So 7 minus 4 would be 3x squared, and then 8 plus 10 for our x values would be 18x, and that is simplified. That's actually all we have to do for example 4. So we touched on this a little bit earlier, but here's the actual definition. The numerical coefficient, or often just referred to as the coefficient, is the numerical factor, which is constant, accompanying the variables in a term. So remember we said, like if we have 3x, this is our variable, and this is our coefficient. So we have 3x squared minus 7x squared plus x squared. So in 3x squared, our coefficient is the 3. In negative 7x squared, it's negative 7. And remember, it's like saying plus a negative when we see a minus sign. So it's negative 7x squared is negative 7. And then whenever we just have a variable with no coefficient out in front, there is an implied imaginary number 1 there. So we have just one of those x squared. So in our x squared, the coefficient is 1. So when we're combining like terms, which we've already practiced doing, but here's the steps laid out for us. We want to identify the like terms, and then we want to combine like terms by adding their coefficients. And remember, if we see 3x squared minus 7x squared plus x squared, like we were just looking at, it's like a plus a negative. So we're just taking our 3 minus 7 plus our imaginary 1. We're doing all of that first, and then we're keeping our x squared. So 3 minus 7, or 3 plus a negative 7, is negative 4. Plus 1 would be negative 3, so we have negative 3x squared. Example 5, we're all the way at the bottom of page 58. So it says simplify. So what are we working with here? Well, let's just start at the beginning. I have an x to the third power, so 8x to the third power. And I have a 1x to the third power, and a 4x to the third power, and a 6x to the third power. Then go back, see what else we had. We had x squareds. This is a negative 1x squared, and another negative 1x squared. So they've color-coded them for us, and we can go ahead and start combining. So I've got 8 plus 1 plus 4 plus 6 is 19. Let's jot that down to the side so I don't forget. 19x to the third. And then I have a negative 1 and another negative 1, which would be negative 2x squared. So it's 19x to the third power minus 2x to the second power. I really like using underlines so when we're working across, so that you can see that you underline it as you're adding it in your head, so that you see that you have included all of them, you haven't missed anything. Then example 6, another simplify. So this time our terms are getting a little bit more complex, so we need to be really careful with them. So starting at the beginning, we have a 4x squared y. So x squared y. Do we have any other x squared y's? Yes, we do. We have one more. Negative 10x squared y. But that's it. No more x squared y. So then we'll just start at the beginning again. I have a 5xy. And then I have another 5xy. Or sorry, another xy, but it's 22xy. Then keep moving down our row. Now I have a negative 8x and a y. So this is again where you might want to use colored pencils to underline it, or you can use multiple lines to show the difference between the different ones. I've color-coded them here on the slide so we can see them more easily. So first off, we'll combine our 4x squared y and our negative 10x squared y. That'll give us a negative 6x squared y. Then I have the 5xy and the 22xy. That'll be a positive 27xy. And then we just have one x value and one y value, so there's nothing to combine there. We just need to remember to copy them down. And there you can see we now just have one of each of those terms, so we are done. That is simplified. Hang on with me there. There's a lot of examples. We'll try to get through them here. So example 7, again, we're simplifying. This one gets even more complex. Now we have an x squared yz, an x squared y, an xy squared, and an xyz. So if you take a good look at those, even though we have x's and y's and squareds repeating throughout, there are none that are exactly alike. So believe it or not, this one is already simplified. This expression contains no like terms. It cannot be simplified any further. Moving on to example 8 then. So example 8 says 2x plus 5 plus the quantity of 3x minus 9 minus the quantity of x minus 6. So to simplify this one, we are actually going to have to combine, or I'm sorry, we're going to have to distribute before we can combine like terms. We're going to have to drop those parentheses. So whenever there isn't a number in front of our parentheses to distribute, there is an imaginary 1. So when we distribute, we're going to have to take 1 times 2x and then times our positive 5. So we'll have 2x plus 5 without the parentheses, plus our positive 1 times 3x is 3x. And then we have a positive 1, so we did that one, times a negative 9, which is going to give us a negative 9 now. And then we have a negative 1 distributed to our x, which is going to give us a minus 1x, or just minus x. And then negative 1 times negative 6, which is going to give us a positive 6. So now our next row looks like this, just like I just wrote out there for you. 2x plus 5 plus 3x minus 9 minus x plus 6. And we've color-coded it so we can see our like terms. We have our x's, and we have our terms that do not have a variable in them. It's just the constant by themselves. So we have 2x plus 3x minus an x gives us 4x, and then 5 minus 9 plus 6 would be 2. So in simplified view, we see 4x plus 2, and that would be our final answer there. Example 9, again, we're going to have to distribute. This time we really need to pay attention to the way they're distributing with these extra variables. So we have 3k times k. Well, what would k times k look like? It looked like, what if we had 2 times 2? Well, that would be the same as 2 squared. So k times k is going to be k squared. So we have 3k times k, so it's going to be 3k squared, plus 3k times 2. Well, we're just going to multiply our 3 and our 2. 3 times 2 is 6, we'll have 6k. Then we have a negative k. We're going to have to distribute to our k and our negative 1. So a negative k times a k is going to be a negative k squared. And negative k times negative 1 is going to give us a positive 1k, or just positive k. Then let's separate out so we can see where our like terms are. So we have the k squared, and we have a regular k. So 3k squared minus k squared would be 2k squared, and 6k plus k is 7k. So we have 2k squared plus 7k. We're getting down to the end here. Example 10. So this one we're going to have to use the distributive property and a little bit of order of operations here. We're going to have to go to the innermost set of parentheses first and distribute that. So we're doing the 4y distributed to the 2x minus 8y. So just like whenever we have a 4 times the 2x, now we're just going to multiply the y into that mix too. So it'll be 4 times 2 is 8, and y times x. So it'll just be 8 times y times x. And then we'll take the 4 times the negative 8 on the inside will give us negative 32, and y times y will be y squared. So remember, when we're distributing these, we are multiplying the coefficients and the variables. So now within our set of brackets, we have some like terms we can combine. We have the 3x and the negative 4x. So those combine and they will become just a negative x. And then we're going to have to get rid of that set of brackets, and we're going to do that by distributing our imaginary negative 1 that we had going on in front of there. So we're going to have a negative 1 times a negative x, a negative 1 times 8xy, and a negative 1 times negative 32y squared. Basically, it's just going to, if we have a negative times a negative, it's going to make it a positive times a negative, it's going to make it a negative. So now we have plus x minus 8xy plus 32y squared. And now we're good to go ahead and combine our like terms. So we only have one set of like terms here. We have our xy terms. And we have a negative 8xy plus a 5xy, which will give us a negative 3xy. So in simplified all the way terms, we have 7x squared minus 3xy plus x plus 32y squared. So thank you for hanging in there. It was a long lesson. There's a lot of information in here, but a lot of it is very similar. So just let me know whatever questions you have and we can work through these. So check out the assignment and let me know how I can help you.